Students, this is lesson 8.4. We're going to be talking about prisms and pyramids. Prisms, and cylinders. Our key question here is how can we find the surface area and the volume of prisms and cylinders? Now, a prism is simply a solid with two bases connected by rectangular faces. So two bases connected by rectangular faces. So here would be your rectangular faces. And then we have your two bases. That would be one base, that would be the other base. So that would be a prism, two bases connected by rectangular faces. Now a cylinder is a solid also with two bases. So there's one base. There would be the other base. And it's connected by one rectangular strip. So technically, this strip around, like a label on a can, that's a rectangle. In a prism, the bases, these two bases, always have these three qualities. One, there's two of them. Two, they are congruent. Three, they are parallel. So for example, these two bases, they're congruent, they're parallel, and there's two of them. So taking a look here, in the prisms and the cylinders, the bases, there are always two of them. They are congruent, and they are parallel. Let's take a look at this first one here. Okay, so you have to have all three qualities. Two of them, they're congruent and parallel. So let's go through several examples. So in this trapezoidal prism, there are two of them. They are congruent. But they're not parallel. So in this one, the shapes that would be the bases would be these two greens. These would be considered the bases. Base does not mean bottom here. Bases, there are two of them, they're congruent, and they're parallel. In this one, these would be the bases. There's two of them, they're congruent, and they are parallel. In this one, these would be the bases. There's two of them, they're congruent, and they're parallel. This one, what I'm about to shade, is not the base. That yellow is not the base. The reason is there's not two of them, they're not congruent, they're not parallel. The two, the congruent and the parallel, would actually be these right triangles. What I'd like you to do is just take a minute real quick and shade these three, what you consider the bases to be. Just take 1 minute. Ready, go. Okay, let's take a look and see how you did. So in this case, those would be the bases. In this case, these right triangles would be the bases. And in this case, this stair step and its match on the other side, those are the bases. Now, in all the equations you're going to learn today, when we talk about the base, we always mean the area of the prism's base. Therefore, you need to have the following area equations memorized. When we talk about area of the base, we're going to use a capital B. So a capital B always means area of the base. So, for example, in a rectangular base, our base area is length times width. In a triangular base, that's going to be base. Notice I'm using a lowercase b there, times height over 2. Lowercase b means it's just a segment. In a right triangle, it is leg times leg over 2. And in a trapezoidal base, we average the bases, so base plus base over 2 times the height. Regular polygon is perimeter times the apothem over 2. And of course, a circle is going to be pi r squared. So whenever you see in any of our equations, whenever you see a capital B, it can mean any one of these. Now, for all prisms and cylinders, we should be able to find both the surface area and the volume. When we talk about height, it's very important. When you have a can, it's really easy for you to identify the height, right? That would be the height. But if I turn the can sideways, there are my bases. Height always means the distance between the bases. So that can mean, even if it's sideways, height always means the distance between the bases. Now, volume of a prism, real simple. Volume of a prism, you start with the area of the base. So in this, we would start with the area of the base, however that is defined. Okay, that would be the area of the base. We're going to use a capital B here. That means area of. And to find the actual volume, all we do is times by the height. So it's base times height. And that B there means area of. That's volume of a prism and a cylinder. Base times the height. So we're going to go 3 examples here. We're going to find the surface area and the volume of these. So right here, we're going to start by finding, we're going to draw a net of this. So I'm going to pull out and then this is my rectangle. And then I have another circle. So to find the surface area, it's the area of everything. So here, I know the area of that is pi r squared. And I know the area of this is a rectangle, so it's length times width. So here, I'm going to do 2 times the circles. So that's 2 times pi. My radius is 9 squared. 2 times 81 pi. So my 2 bases is 162 pi. We don't have units, so we just write units squared. Now I have one rectangle, length times width. My width here technically is my height. Can you see that? That's going to be 18. Now the length is a little trickier. This length, if I take here and I wrap it back around, all the way around, very important, you need to see that this length here is actually the circumference of the can, which is d pi. So to do length times width, I'm going to do d pi, which is my length, so my diameter is going to be 18 pi, times my width, or which is my height, which is 18. 18 squared. I get 324 pi. Now I add these two up. And my total surface area equals 486 pi units squared. That's my surface area. Now my volume is simply base times height. So my base, I shade it. Capital B means area of times the height. That's volume. Now for every time we do volume, we have to define what the base is. The base is a circle, so it's going to be pi r squared times our height. So it's going to be pi 9 squared times our 18. So 9 squared is 81 times 18. And my volume, therefore, is 1456 pi units cubed. So that's surface area and volume of one cylinder. Let's do one more. Example number 2. Our first job is to draw a net. So we're going to draw a net of our base here. And then we have our faces, of which there is 5. 1, 2, 3, 4, 5. Then we have the bottom base. Not very graceful, but we'll manage. Okay, so now we want to find the surface area. To find the area of these guys, this is just length times width. To find the area of the regular polygon, that's perimeter times apothem over 2. So I'm going to do it this way. I have 2 pentagons. So I'm going to make 2 times that. So that's 2 times perimeter times apothem over 2. So now I'm going to start working what I have here. My perimeter is going to be 10 times 5. My apothem is 6.9 over 2, and then we're timesing by 2. So technically you should see that those 2's cancel there. So I'm going to go 50 times 6.9, and I get 345. So the area of my bases is 345 feet squared. And then I have 5 times my rectangles. So I have 5. My length and my width is 10 times 10, which is 100. So it's 500. So I simply add those 2 together, and I'm going to get, for my surface area, I get 845 feet squared. Volume equals base times height, so volume equals area of the base times the true height. Now I define my base here as perimeter times apothem over 2 times my height. So my perimeter, you walk it around as perimeter, that's going to be 50 times the apothem, which is 6.9, over 2, that's your base, times our height, which is 10. So 50 times 6.9 divided by 2 times by 10, and my volume is going to be 1725 feet cubed. If you were absent, you can skip this problem. Go straight on to pages 7, 8, 9, 10, 11, and 12.